Hi everyone, we're going to look at some harder examples of algebraic substitution in this lesson, following on from our last lesson, if you've been following along in our curriculum booklets. So let's look at some of these harder examples. So our first one, we've got brackets involved. Evaluate 2 upon x subtract 1. Now remember, this bracket means that I'm multiplying 2 by everything inside the bracket. And it tells me that x is -5. What I'm going to do is I'm going to substitute that value of x into the bracket. So I've got 2, and then in my bracket, just simply replace your x with the -5, like this. I need to do this calculation in the bracket first. So I'll do -5 take away 1, which gives me -6. That's what my bracket becomes, and I just rewrite it like this. And then remember, brackets mean multiplication in this case, so 2 multiplied by -6 gives me an answer of -12. So that's the value of the expression when x is -5. Pause the video and give this question a go. So evaluate -4 upon 2 subtract y when y is 1. Let's go ahead and substitute that value of y into my bracket. So just simply replace the y with the number 1, like that. Do the calculation inside the bracket. 2 subtract 1 is 1. And then do -4 multiplied by 1 to give you -4. The next example we're going to look at is where we have a double negative, and we have to be a little bit careful here when we're doing this one. Evaluate 10 subtract x when x is -10. So I need to replace this value of x with -10. And what that's going to give me is it's going to give me two negative symbols beside each other. It's going to be 10 subtract -10, like this. And remember, when we're subtracting a negative, that's equivalent to adding the corresponding positive. So subtracting -10 is equivalent to adding 10. 10 add 10 gives me an answer of 20. The mistake people make here is that they do 10 subtract 10. But of course, we're not subtracting 10, we're subtracting -10. So this is the correct way to do it, and that's not correct. Pause the video and give this one a go. So evaluate -2y subtract 3 when y is -5. So we're not subtracting a negative this time, but what we are doing is we're multiplying two negatives together. Let's go ahead and replace this value of y with the -5 like this, and I show that using brackets. So this is -2 multiplied by -5, and then I'm going to need to take away 3. Okay, go ahead and do your multiplication before you do your subtraction. So -2 multiplied by -5 gives me an answer of +10, because a negative multiplied by a negative gives me a positive. I then need to take away my 3. So all I've done there is I've done this part, which gives me 10. Then do 10 take away 3 to give you 7, and that's your answer. The next example we're going to look at is where we have multiple variables. And what we mean by that is, in this case, we've got x and y. Evaluate 6x subtract 4y when x is equal to 0.5 and y is equal to -2. Let's start by replacing our variables with the numbers that they correspond to. So I'm going to have 6 lots of x, and x in this case is going to be 0.5. Then I'm going to take away 4 lots of y, and I'll place that value of y inside the bracket like this. I then want to think what operations I have going on. I've got multiplication. I'm doing 6 multiplied by 0.5, and I'm doing 4 multiplied by -2. And then I have subtraction. I want to do my multiplication first. So I'll do 6 multiplied by 0.5. Well, 0.5 is a half. 6 multiplied by a half is 3. And then what I've got here is -4 upon -2. And there's two different ways you could think of this. I could think of this as I'm taking away 4 multiplied by -2. I'm taking away -8. Okay, which is of course equivalent to adding it. That's one way to think of it. Or I could think of it as I'm doing -4, so include that symbol initially, and do -4 multiplied by -2, which is equal to +8. Either way, it does come out at +8. You just have to be a little bit careful. And I think it's good that we understand both ways. I'm going to think of it as I'm subtracting 4 multiplied by -2, which means I have -8 here. Okay, like I said, you could think of it as doing -4 multiplied by -2 to give you +8. But either way, you're going to get the right answer if you think of it properly. Then I'm doing 3 subtract -8. Well, subtracting -8 is equivalent to adding it. 3 add 8 gives me 11. That's my final answer. Pause the video and give this question a go. So evaluate 2x, add 3y when x is 12 and y is -5. Let's go ahead and replace our variables with the values. So I've got 2 lots of 12, then I'm adding on 3 lots of -5. I'll do my multiplication. So 2 multiplied by 12 gives me 24. And then I'll do 3 multiplied by -5 to give me -15. Then I need to do 24 add -15. Well, of course, that's the same as 24 subtract 15. And then 24 subtract 15 gives me an answer of 9. Again, with this part up here, it's just worth explaining. We could think of this as +3 multiplied by -5 right away, which takes us straight to -15. Or like I treated it, I could think of it as I'm adding on 3 lots of -5. Well, 3 lots of -5 is -15. I'm adding on -15, which is of course equivalent to subtracting 15. So either way, we do get that -15 or subtracting 15. They are the same thing. We just need to be careful how we think of it. Our next example, we've got some powers and roots. Evaluate 3x squared when x is equal to 5. Let's go ahead and substitute our value of x into this expression. So I've got 3 lots of x squared. Well, I want to do 5 squared like that. And then I just follow my order of operations from here. I've got indices, so I'm squaring, and I'm also multiplying. And I need to remember that according to my order of operations, which we might remember using something like BIDMAS or BODMAS, I need to do my indices before I do my multiplication. I need to do my 5 squared first. 5 squared is 5 multiplied by 5, which is 25. Then I do my multiplication. 3 multiplied by 25 gives me 75. So that's my answer. Just be careful with this one. I've intentionally made it very similar to our example, but it is slightly different. So you need to be careful how you do this. Pause the video and give it a go. Okay, let's look at the solution to this. Notice that this time the brackets are around the 3y and then I'm squaring it, which we didn't have in our example that I did. Let's go ahead and substitute in what we've got. We've got y is 5, so I need to do 3 multiplied by 5 and then square it. Now notice the order here tells me I need to do the brackets first. I need to do 3 multiplied by 5 to give me 15, and then I need to square that. 15 squared is 15 multiplied by 15. I'm going to set up my column multiplication to do that because it's a non-calculator lesson. 5 multiplied by 5 is 25, carry over that 2. 5 multiplied by 1 is 5, add on the 2 gives me 7. Then I need to remember I need to put down a 0 here because this 1 is in the tens column. Then do 1 multiplied by 5, and then do 1 multiplied by 1. Add those together, and that gives you this answer of 225. That is your final answer. The next type of example we're going to look at is a quadratic substitution. Now, quadratic is a type of equation or an expression, and we haven't covered that yet in the curriculum so far. We'll cover it in the next few lessons. But even though we haven't covered what a quadratic is, we can still look at how we substitute values into the quadratic, which will be an important skill for later on. Evaluate x squared, subtract 2x, subtract 8 when x is 4. What I'm going to do, like before, I'm going to take my x and I'm going to replace it with the value 4. Remember to put it in brackets like this. Then I'm going to take away 2 lots of x, again putting my value in the bracket. Take away 8. So that is exactly how you type it in your calculator if you were going to do that. We are not going to use our calculator though, so let's go ahead and do it. 4 squared is 4 multiplied by 4, that's 16. Subtract 2 lots of 4, well, I'm going to be subtracting 8, and then I'm going to subtract another lot of 8. 16 subtract 8 is 8, and then take away that second 8 gives me an answer of 0. Pause the video and give this question a go. So evaluate y squared, subtract 7y, add 10 when y is 5. Go ahead and plug in that value of y is 5. I shouldn't say plug in, I should say substitute. Then take away 7 lots of 5, add 10. We'll do our 5 squared. That gives us an answer of 25. And then 7 multiplied by 5 is 35, so I'm taking away 35. And then I'm adding on 10. Let's do this in stages. So 25 take away 35 is negative 10. Then add on my 10, which takes me to the answer of 0. Now, if you notice, in both of these quadratic substitutions, I got an answer of 0 when I evaluated my expression. What that means is that if these were equations, the y squared subtract 7y add 10, and the x squared subtract 2x subtract 8, these were equations, our values that we substituted in would be solutions to these equations. And we'll look at what that means in the next few lessons. The last type of example we're going to look at is where we have real life formulae. So evaluate f is equal to ma when m is equal to 4 kilograms and a is equal to 3 meters per second squared. Now, in the context of this equation, f is force, m is mass, we could tell that by the units, and a is acceleration. This particular equation is one of Isaac Newton's famous laws of motion, where the force is equal to the mass multiplied by the acceleration. So let's go ahead and work out what the force is in this case. So our force is equal to our mass. Well, mass was 4 kilograms, and we're multiplying by the acceleration, which is 3 meters per second squared. So we'll multiply by 3 ms to the negative 2. And then simply multiply your numbers together. So 4 multiplied by 3 gives me an answer of 12. And the units for this are actually newtons, which is the unit of force measurement. Pause the video and give this question a go where you substitute into this formula and try and have a think about what your units are going to be. Okay, let's run through it. Evaluate v is equal to s over t when s is negative 10 meters and t is 2 seconds. So v here is velocity, which has a magnitude, that's a size, and also a direction. S is displacement, which we could think of as distance, but importantly, it is different. It includes the direction. Notice that it's negative 10 meters. And that tells us that it takes into account direction. So if this is 0 meters, this direction is positive. So we might have 10 meters over here, positive 10 meters. And this direction is negative. So that's where our negative 10 meters would be. So distance is what we call a scalar quantity. It just takes into account magnitude, that is overall size. But displacement takes into account direction and magnitude. And then t is the time. So let's work out the velocity of this object. So we have a displacement of negative 10 meters, and I'm going to include my units here on the numerator, and my time is 2 seconds. Now, if I notice what I'm doing with my numbers, I'm doing negative 10 divided by 2, which gives me an answer of negative 5. And I can apply similar logic to my units. I'm doing meters divided by seconds. My units are meters divided by seconds, or meters per second. So the velocity is negative 5 meters per second. If you're using our curriculum booklets, you can now complete exercises 1 to 5. Thank you for watching this video. If you enjoyed this video lesson, it's part of our mathematics curriculum. You can try a free sample on our website at mathslogos.com. We also offer online mathematics lessons for home educating families, co-ops, and schools. So if you're interested in arranging a free trial lesson, drop me an email at scott@mathslogos.com. Thank you.